Consider this chemistry question. This is question 31, JAM 1978. Consider the following exothermic reaction. So we have sulfur 4 oxide reacting with oxygen to form sulfur 6 oxide, or we call it sulfur trioxide. So this is a gas, this is a gas, and this is a gas. Now, the question further says that if the temperature of the reaction is reduced from 800 degrees Celsius to 500 degrees Celsius, and no other change take place, then dash. A, the reaction rate increases. B, concentration of SO3 decreases. C, concentration of SO3 increases. D, SO2 gas becomes unreactive. And E, O3 gas becomes unreactive. Very good. This is a question on chemical equilibrium. So a reaction is said to be at equilibrium if there is no net change in the overall process. That is, when the total concentration of the reactant is equal to the concentration of the product. So there is no difference in the two sides of the equation. So that's when we say that a reaction is at equilibrium. Now, however, if there are certain conditions that take place, so either in the reactant part or the product part, there will be a change in equilibrium. So the reaction may not later be at equilibrium. Now, according to Le Chatelier's principle, which was stated by Sir Henry Louis Le Chatelier, so he mentioned about 3 constraints, so which are concentration, pressure, and temperature. So these are 3 conditions that can affect the equilibrium of a particular reaction. So concentration, pressure, and temperature. But the one that concerns us in this context is the temperature. Now you can see that the question says if the temperature of the reaction is reduced from 800 degrees Celsius to 500 degrees Celsius and no other change. So that means this one is not involved and concentration and pressure are not involved. Now let's deal with this. So you also need to consider that the reaction is exothermic. So according to what is said here, the reaction is exothermic. What do you mean by that? Exothermic reaction is a type of reaction in which heat is given off to the surrounding. So, and in this type of reaction, the enthalpy change is always negative. So the enthalpy change will be negative. That is, change in heat energy is always negative. Now, if you consider this, you see that all of the species, both the reactant species and the product, everything is a gas. So now, but I don't really have business with that, since we are not talking about pressure. It is pressure that takes more. Let me say, it is pressure that deals more with gaseous reactant and product. So, but talking about temperature now. So since the reaction is exothermic, it means the forward reaction will be exothermic and the backward reaction will be endothermic. Now, increase in temperature does not favor for the forward reaction. It does not favor exothermic reaction. So, but decrease in temperature will favor the forward reaction. How do I mean? Since the temperature decreases from 800 degrees Celsius to 500 degrees Celsius, it's going to favor the forward reaction. So it means the equilibrium position will shift to the left. It will shift to the right, sorry, meaning that we will need more SO2 here because the concentration of this is going to increase since temperature is reduced. When temperature is reduced, concentration increases. So now, since temperature is reduced, that means concentration will increase. So it means we need the SO2 to the SO2 will now increase. The concentration of this will increase more since the equilibrium position is shifting to the right. You understand? So it means we can just check our options and see the one that is correct. So that means option C is the correct answer. That is, concentration of SO3 increases. So that is how it goes. But for the backward reaction, increase in temperature will favor the backward reaction. That is, the concentration here will increase. So because the backward reaction will be endothermic, since the forward reaction is exothermic. So the reason why other options are not correct, this one says the reaction rate increases. No, it says the reaction rate increases. That is wrong, because there is decrease in temperature. Decrease in temperature will decrease the rate of reaction. So this is not correct. Check option B, concentration of SO2 decreases. That is also wrong, because it's talking about the opposite of that. Then G, SO2 gas becomes unreactive. No, decrease in temperature does not make this gas unreactive. This is wrong. Similarly, O3 gas becomes unreactive. This is also wrong, because there is no O3 gas at all in this process. Thank you. God bless you.